Well, let me welcome everyone to the Long Coffee Break series. This is a weekly series that we have been doing for quite some time now that spotlights specifics as to a product, a problem in the field, or other engineering type aspects of what we do on a day-to-day basis in HVAC. Today we'll be talking with Scott McMurray. He joins us from, I'd say, Aldes, and he is a business line manager. We'll be talking about constant airflow valves. I equate those a lot of times to hydronic systems with automatic flow valves. We use those quite a bit, but we don't use the automatic flow valves that are available for the airside equipment as much. And I think you'll see through the presentation today that there's a lot of places where you might be able to employ those to enhance your designs as we go along. So welcome to the seminar. We'll be talking for about 15 minutes. And if you have any questions, please type them into chat. We'll keep the lines silent until that point. We'll go through the questions that you may have typed in. And then after that, we can open up and you can ask questions directly if you'd like to do so. So please do hold those questions till the end or type them in as you have them occurring. And again, this is a weekly presentation. At the end of this, I'll talk a little bit about what we're going to do next week. But at this point, Scott, whenever you're ready to go.
Perfect. Well, thank you very much for the introduction, Jeff. As you said, we're going to be talking briefly this morning about constant airflow regulators. Our version of the constant airflow regulator, the latest and greatest on the market, we call it the CAR 3. A lot of you are probably familiar with our product, the old version of the product, which is the CAR 2. So we launched the CAR 3 towards the end of last year, so around August, September of 2020. So some of you may have already seen these laid out or placed some orders for some, but it's still relatively new for us. And certainly, even though we've been selling constant airflow regulators within the market, within North America for the past 20 plus years, it's still a product that a lot of people have not heard of. So it's a good opportunity to spend this time and look at what these products are, what they do, what they're for, what the benefits are, and give you kind of like a snapshot of the product and the applications. So what we're going to be talking about today, very briefly, just to highlight kind of the functions of the airflow regulators and what it is, what makes it special, what makes it useful within these types of applications, being predominantly high-rise or large central systems where balancing is a challenging thing, right? So we'll be touching base on a bit of that. So then we'll go over the performance of the device, what makes it unique compared to other options that are on the market. And then we'll kind of expand upon that and talk about what options are available outside of just the airflow regulators by themselves. So the purpose of the constant airflow regulator is to balance, right? The easiest way to think of this device is it's a balancing damper, but it's automatic. So instead of having a manual balancing damper where you have to take an airflow measurement and then make an adjustment, a manual adjustment to an OBD or maybe an iris damper or something along those lines, this device, you can order it factory set at a specific CFM, or you can field adjust it and slide it into the duct or install it as part of an assembly. And as the pressure within the system changes, it's going to automatically adjust itself to maintain that set airflow. So it's an automatic balancing damper. So you can think of it as no different than any other balancing damper on the market, just with the difference being that it's going to maintain that airflow as your system parameters change, whether that's filters loading or stack effect, or operable windows and doors, or devices within an apartment turning on and off, like range hoods, dryers, things like that. These are going to compensate for those changes in static pressure within the system to maintain airflow all year long. And what that's going to do for your system is that means that it's going to reduce the load on my heating and cooling. Most commonly, what you're going to have within a system that's out of control, especially in a cold climate, especially in vertical buildings where you have stack effect, Stack effect is going to result in excess ventilation, right? You have stack effect, that means that you have more air leaving the building than what you want due to that natural process that we can't avoid. So by controlling what can go into my vertical shafts, right, specifically risers and things like that, by controlling the pressurization of the building, I'm going to reduce the load on my heating and cooling system. Well, heating in the winter and cooling in the summer, because you're still going to have these challenges in the summer as you have operable windows and doors, people open up their balconies. You're going to have this big swing in airflow, and your DOAS system, your makeup air system, is going to have a difficult time trying to compensate, and then going to be putting a lot of extra energy into those systems. Additionally, more control means better indoor air quality, right? So by having better control over my building pressurization, I'm going to reduce potential contaminant movement from one space to the next, right? A lot of us have lived in high-rise buildings over the years, and just about everybody that I know that has lived in that kind of project or building, they can say, oh yeah, there's always that time where you can smell what your neighbors are cooking. What's the reason for that? What's the driving factor for that? It's not because smell can just magically move through walls, it's pressurization. And so by maintaining control over those systems, you're going to have better indoor air quality. And it's not just, in regards to smells and odors and things like that. It's CO2, it's humidity, it's, airborne illnesses, which are the things that a lot of people like to talk about these days. By reducing contaminant movement, you're going to have better indoor air quality. And by controlling and making sure that you maintain your correct ventilation rates, you're going to make sure that you have good indoor air quality. And we do all of that with the CAR3, right? So the key product in this application and in all of our assemblies that are in the airflow and zone controls product range for Aldis, they're all based on the CAR3. So once you understand how the CAR3 works, then everything else will be, very easy. So how does the CAR3 work? Right, so the CAR3 is a modulating damper, and what that means is it's a damper that you modulate how much free area you have, right? It works just like any other balancing damper, just the difference is, in terms of you creates however much pressure drop is necessary to maintain a certain airflow. And the way that it does that, and I have one here, and hopefully people can see it through my white background. So as I have an increase in pressure, right, I'm going to have an increase in velocity, and this damper is going to rotate. And so what I am doing here is this device is going to create more pressure drop than it does in the relaxed position. So basically, this movement here is the airflow regulator moving through its operating range. So with very little pressure, it's going to be more on the bottom, more relaxed, and with more pressure, it's going to be more closed. And it's going to automatically adjust itself to whatever position is necessary in order to maintain flow. So as I have, again, things like filters loading, fans changing speed, stack effect, that device is going to automatically adjust to maintain constant airflow, right? So it's a constant airflow regulator. So how is that going to save us energy, right? So save energy and IAQ, right? So what we have shown on this slide here is a pretty typical kind of application, right? Where up near the fan, you have more pressure. Typically, you're going to have more flow. Down at the bottom, less pressure, less flow. We've done a lot of case studies where we've done before and after measurements, and it's very typical. This is pretty consistent what we see, unless you've got a stack effect issue, and then you're actually going to have a lot of airflow at the bottom of the building. But this is pretty common for a day-to-day, and obviously I'm over ventilating at the top and I'm under ventilating at the bottom. My over ventilation at the top doesn't do anything for my air quality other than cost a lot of money. And at the bottom of the building, people don't have good indoor air quality. So by correcting all of this, and like I said, we have case studies where it shows by just having the airflow that you need and not more and not less, you can save a tremendous amount on your utilities. We've seen 27% just of savings on the utility costs for an entire building just by installing the airflow regulator. So very, very short ROI. In that case, it was like 9 months. So it's kind of a no-brainer. So talking about the airflow regulator itself and going into a little more detail in terms of what it can do, especially in regards to the CAR 2, right? Because this is kind of an introduction to the CAR 3, not just as a practice, but as a product and the evolution of the product. So compared to the CAR 2 had finite airflow rates. So it had to be ordered at 50 CFM, for example. By comparison, the CAR 3 is adjustable. And now we have the ability to adjust within a range. So not only do we have the ability to adjust within a range, which is the range itself is much bigger than what we had by size in the CAR 2. So for example, the CAR 2 in 4-inch only went up to 60 CFM. The CAR 3 in 4-inch goes up to 85 CFM. So we've got an increase in airflow by size, which is going to potentially save money compared to the CAR 2, but it's also adjustable. So if for whatever reason we need to adjust the airflow rate in the field, we can do that. It's very simple to do. So what you can see on the right side of the screen here, everything that's shaded blue by size is available. You can hit whatever CFM you want within that shaded area just by measuring and making your adjustment. Or again, you can do a factory set and then they'll follow the curves that you see there. So today we have 4, 5, and 6, but very soon we will be offering 8 and 10, and both or all of those sizes are available in both what we call low pressure and high pressure. Low pressure will handle 99% of projects with an operating range of 0.12 to 1.2, whereas the high pressure does 0.4 to 2.6. So that's for more of like a special application. Again, certainly a bulk of projects will be handled with the low pressure. For adjustability, we use a worm gear. And so the worm gear is ideal for this application because, just like a steering rack on a car, I can put my input into the steering wheel, but I can't put the input into the tire and turn the whole thing. Same idea here, right? Airflow is not going to impact the set point of this, nor will physically touching it. That's a problem that some of our competitors have, just changing the airflow rates on accident. Additionally, that worm gear passes all the way through the assembly. So you can see that dial is on both sides. The indicator showing the CFM is on both sides. So you can make your adjustments in supply or exhaust. So that's an industry exclusive. And then of course, how we put it into an assembly is also something that only we do from Alvis, and that is we've integrated a Twistlock feature into the assembly. Gives it a very, very secure fit. So you can see the pattern in the metal. And so basically it just snaps in, makes it very, very simple on our end to do the installation and make the assemblies, but also in the field, if you ever have to change the airflow rate or the position, let's say you accidentally ordered it in exhaust and you need supply, you can pop it off and put it back in the other way. So it's a very simple thing for working with in the field. And then in terms of what options are available within the assemblies, and this is certainly the best way to go, we can do it with a grill, with a fire damper, with a round connection, supply or exhaust. It all comes as a single piece. I actually have something sitting on my desk here where basically you would get it just like this. So now you have an automatic balancing grill as a complete assembly. So it makes it very, very easy to install. They're also available in register boxes, again, fire dampers, ceiling radiant dampers, whatever you need for your application. And the big reason that we push for assemblies is because of images like this, right? This is very common, unfortunately. Contractors love to cut corners and reduce cost anywhere that they possibly can. And not all contractors, of course, but it's not uncommon. And what you end up with is, this, right? Instead of getting an assembly that has a guarantee and a warranty, and you know what you're going to get, and the performance is going to be guaranteed, obviously we can't guarantee whether, we're talking from the engineering standpoint, the manufacturing standpoint, the representative standpoint. Nobody can guarantee performance when you have this type of installation. So we always recommend doing, factory assemblies. You know what you're going to get. The performance is guaranteed. We stand behind the product. It has a warranty, 7-year warranty. So it makes it just that much easier to deal with. So always we recommend, if you're going to need the grill, just go ahead and buy it as an assembly. So that's it from me. So I'll open it up to any questions if anybody has any questions or comments or concerns or.
Well, thanks, Scott. Thank you for the information. And yeah, please do type in any questions that you might have. We haven't had any come through at this part, but a question I'm often asked, Scott, is does this replace balancing dampers?
Exactly. So the airflow regulator, the easiest way to think of it, it is a balancing damper, right? So you would replace it in the exact same locations where you would have a balancing damper. And actually this assembly that I have sitting on my desk is a perfect example, because traditionally you would see the grill with the balancing damper mounted directly to the neck of the grill. That's all we're doing with this, right? We're mounting the airflow regulator directly to the neck of the grill to have an assembly that it installs with the grill, so no different than any other grill on the planet, but it's adjustable through the louvers of the grill, so you can actually see in there, and you can make your adjustments with a screwdriver just like any other balancing damper on the planet, and it makes it that much easier to install, maybe make some adjustments in the T&B process.
Very good. Now, where I see this working so well in the designs that we've done in the past is certainly grills, but we've used them on chilled beams quite a bit, and that meters out the flow to each of those beams. That's a very critical thing when we're talking about chilled beams and their performance. And then you're able to vary the static pressure. Again, it's a much smaller outdoor air system that we typically provide to those, but you're then getting assured that you're getting the right flow to each one of those devices. They're able to work correctly in that situation. But we talked a little bit about hotels. That is a perfect example of where we want to try and maintain that pressurization. And we've all been in that hotel that has suffered from the lack of outdoor air and some of the issues and problems that you can smell or see as soon as you walk into the place.
Absolutely. Especially in a cold climate where you have an indoor pool. If you can smell the pool in the hallway or in your room, that just means that there's a pressurization issue. Too much exhaust, not enough supply, and balancing those systems with something like the airflow regulator is one easy way to make sure that you maintain positive pressurization when you're in close proximity to something like an indoor pool.
Yes, and one place where it would help too is the term retro commissioning. There's a lot of people that don't do that or forego that, and in our buildings, as they do age, they lose efficiencies because they're only at their peak right after it opens, right after it has been commissioned. So retro commissioning is the snap. You don't have to get it. I hate to use the term, the Ron Popeil, set it and forget it, but that is what you're getting from these automatic airflow valves, and that's what you're asking for.
Absolutely.
Now, when you install this, Scott, what does a balancer need to do in order to assure that it's working properly?
Yeah, so when we see these projects, obviously, we definitely promote some savings on the balancing side, right? If you're ordering it factory set, then what's the point? What's the point of ordering it factory set if you just have to go back and balance it? So, we certainly recommend doing spot checks. It sounds oversimplified, but I always tell people to check at the extremes. Check at the bottom, check at the top, traverse the riser, get at minimum those 3 measurements, because if it's working at the bottom and it's working at the top and you traverse the riser and, if you're supposed to be getting 1,000 CFM and you're close to 1,000 CFM, there's no way that it's not working, right? That's the easiest way to look at it. Now, if you start doing, if you start to see errors within that, like I'm getting no flow at the bottom, but it's working fine at the top, you know, then we can start to look at, okay, maybe there's a leakage issue. Maybe there's a big hole in the duct that somebody missed. You know, maybe we need to turn up the fan pressure. Maybe we need to do this, you know. So if anything, the airflow regulators during the troubleshooting process, a lot of people like to point at the airflow regulator as a source of the problem, but more often than not, they're a source of the solution to get the system to where it needs to be in terms of if everything's working and it allows the airflow regulators to work, then you know that the entire system is performing the way it's supposed to.
Well, and that static pressure, that upstream static pressure is certainly a big driver for the performance. We just need to be within that range. But a question has come in is, do you have any suggestions on how to make sure you are using the correct static pressure ranges, low versus high?
Sure. So again, the low pressure does 0.12 to 1.2. So it's going to handle a vast majority of projects. If you're in excess of 1.2 inches, then that's where you would definitely want to consider doing high pressure. Well, you would have to do high pressure because you're outside of the range of the low pressure. But when we've got, you know, maybe you're going to exceed 1.2 every once in a while, but you're always going to be above 0.4, which is that's where the high pressure starts to work. Then you can look at maybe doing a mix, right? So we've done a lot of projects where we'll do low pressure at the bottom and then high pressure on the top few floors. You know, this would be for a 20-story building, for example, right? So I'm always going to be close to an inch, maybe a little more on the upper floors, which you're at the end of the operating range for the low pressure, but you're in the middle of the operating range for the high pressure. So, you know, you might as well just go ahead and use that. So certainly there is an opportunity to do both, use high and low pressure. The easiest answer that I have is don't overthink it. If you think you're going to be at the higher pressure, closer to an inch, you can use high pressure. If you want to be consistent and you don't want to worry about, you know, how is it going to be packaged or received, which by the way, we package things by floor for free just because that's the easiest way for everybody. Then, you know, we can package it so that all the high pressure are in their own box, all the low pressure in their own box. And so again, it's just easiest to don't overthink it.
Well, and some of the mechanics I would suggest to a specifying engineer on how to do that best is in your specifications, certainly list both and the particulars to each one of those. I would actually petition to have a schedule that shows both of those on the schedule. And then you could put notes on that schedule, say, make sure that you apply it to the right location and static pressure. And then through the submittal process, you could have the rep as well as your comments to those submittals to say, hey, look, I'm not going to tell you where the high and low pressures need to be, but you need to put the right ones in the right space. I think that would help a specifying engineer as well.
Absolutely.
And then I guess the end of the day, as long as you buy the Aldi's/Long product, you'll never have that problem because we're experts at this and we can help coordinate that with the contractor to make sure they get it in the right spots. And there is some training that needs to happen probably on the first few projects. But I often find that if you have something a little bit different than what you've done before, like a belt tensioner on a fan or a factory mounted VFD on a pump or something like this, an airflow regulator that we haven't seen in the past, a great place to emphasize that is in your details and in the schedules because people tend to pay the most attention to those areas. And it might be that after 5 or 10 years of using these that you don't have to worry about that. But I think listing them, at least for some of your first projects, will give an indication to everyone bidding it that you're doing something a little differently here. And funny enough, the balancer that actually picks up on this and that understands this, he's going to be able to significantly lower his price. So you're going to have some cost savings there. And those guys that are the smart balancers that you probably want to do work with anyways, for whatever that's worth, they'll recognize this, they'll price this appropriately, they'll get that job, and then they'll be able to work with it. And they're part of the process in getting the right ones in the right location too. But the question came in too, is there a cost difference between the high and the low pressure valves?
There is a cost difference. You know, we don't use like I said, the low pressure handles 99% of projects. And anytime that, you know, on manufacturing versus purchasing from any standpoint. The more you buy of something, the less expensive it gets. And because we simply don't produce nearly as many high pressure as we do on the low pressure, there is a cost difference.
All right, we've got another question that came in, but Scott, if you'd flip to the last slide.
Sure.
But the question is, what is the cost difference between the standard volume damper and one of these constant volume dampers? How would you answer that question?
So as a manual balancing damper versus the airflow regulator, certainly there's a pretty significant cost difference. You know, a manual balancing damper, especially on who you buy it from, you know, there are cheap grills, right? There's very, very inexpensive grills on the market that integrate, you know, the air or the balancing damper right into the grill, and you can buy those for, you know, less than $10. Whereas the airflow regulators, if you were to buy the grill with the airflow regulator and everything as an assembly, you know, it might be $50, something like that, depending on quantity and size and everything else. You know, there's 1,000 variables. But the part that saves, it's not the upfront, because there's always going to be the argument, and Jeff, you said it perfectly. In theory, the building is going to be the most efficient it'll ever be on day one, right? So comparing day one airflow regulator versus day one balancing damper, you're not going to have the obvious savings. So from an energy modeling standpoint, it's impossible to show upfront savings on an airflow regulator, because per your energy model, you're saying you have 35 CFM where you're doing 35 CFM. But energy model versus reality, there's a huge difference, right? Just the process of balancing. You know, it's never perfect, day one or otherwise. It's not possible with a manual balancing damper. It's simply just not possible unless you have one person for every single register, all trying to balance the entire system simultaneously, because that's what the CAR 3 does, right? You balance everywhere automatically simultaneously, and that's where the savings are. It's reality versus expectation. And in reality, the CAR 3 will guarantee those numbers 24/7, 365 for 7 years. Ask a balancer to put a warranty on for 7 years for every register in the building, and then we can talk about savings.
Well, and the way I answer that often is it certainly is a price increase. And you might talk to 2 to 3 to 4-fold cost increase on just that particular device. And there's quite a few that might be in the project for sure, depending on where you use them and how strategic you are maybe with their employment. But what I would say is that price is very small in comparison, not only to the savings you're going to see from retro commissioning, possibly from balancing, but then also the cost of the entire project. We're talking, you know, a significant increase on a very inexpensive piece of equipment. Whereas I have people that'll, you know, take a VE option to take out a $2,000 to $3,000 sound attenuator out of the project, which again adds a ton of value, but they see it as an upfront savings. I mean, that $2,000 to $3,000 can pay for a ton of these airflow regulators. So it's certainly an enhancement. You want to make sure that your owner is on board with that and realizes that there is an increased cost, but it's the enjoyability of the building over time, I think, that is really the root question of what you might want to provide with these type of devices, as well as solving some of those problems. And we've seen them in retrofits quite a bit of times when we have a real big issue with one particular room, especially as we have a varying system, getting the right amount of air. These can be easily retrofitted to existing ductwork and to solve a lot of those problems too. So
absolutely.
Well, great questions, everyone. We'll draw this to a close at this point, and I want to thank you for attending our coffee break. Next week, we are going to be doing another one. We're actually going to be talking not about the fans that we talked about last week, but building electrification in central systems, mainly talking about heat recovery chillers and what can be done. We see a lot of need for that these days as places like the University of Utah and others that are trying to offload everything onto the electrical side. How do you do that efficiently, effectively, and in the ranges that you need for heating and cooling for your buildings without having a boiler, essentially? So please join us for that. and you'll see emails to that effect coming in through next week. So you're welcome to stay on. We'll take any other questions. You can unmute yourself and go from there. But at this point, thanks all for attending.